It's Daddy Cause. In this video, we'll be looking at nitrogen and compounds of nitrogen. Nitrogen exists as free element in air and it consists about 78% of air. Actually, air is majorly nitrogen and oxygen. Oxygen is about 21% of air. In air, nitrogen acts as diluent, helping us to slow down the activities of oxygen in air. Activities like corrosion and combustion. For example, the guy smoking cigarettes in my screen now would not have done that without becoming a burnt offering if there is no nitrogen in the air. It's because of nitrogen that you can light your matches without the fear of explosion. And because of nitrogen, you can use iron material, metal material to make building and structures, because otherwise it will have just rusted at the speed of light. But because of nitrogen, the activities of oxygen were suppressed. So that's how it helps to serve as diluent, as solvent in air. In a combined state, you can find nitrogen as ammonium salt. It also exists as Chile saltpeter. Chile saltpeter is sodium triisonitrate 5 and is present in protein, in urea, in vitamin B complex. How do we make nitrogen in the laboratory? Number one, we can make nitrogen from air, and it can also be made from nitrogen containing compound like ammonium diisonitrate 3, like nitrogen 1 oxide, which you know as laughing gas. From ammonia itself, you can make nitrogen. You can also make nitrogen from diammonium heptazodichromate 6. So let's look at how you make nitrogen by this method. To make nitrogen from air, you have to remove other components of air like carbon dioxide and water, dust particles. Then you now move ahead and remove oxygen. So the first thing you do, use an aspirator bottle to push air through sodium hydroxide, that's caustic soda. So when you pour water, as you can see on the screen, when you pour water through that aspirator bottle, the air in the bottle will be pushed up and pushed into a bottle containing caustic soda. Now we know that caustic soda will absorb carbon dioxide. So the remaining component of air will be passed through heated copper. You can see the heated copper inside combustion tube. That heated copper is performing the function of absorbing oxygen. Then what you have majorly is nitrogen, which you collect over water. So you have to take note of the reactions occurring in each of those bottles. In the reaction occurring inside NaOH bottle, it's a form of neutralization reaction where CO2 and acidic oxide is reacting with sodium hydroxide and an alkali, a strong alkali. The one occurring inside the combustion tube is a form of oxidation reaction where the oxygen is being absorbed by the copper metal to form black copper 2 oxide. Take note of that before your hydrogen will be collected over water. Your nitrogen is collected over water because it is insoluble in water. However, it is good to note that this nitrogen that is collected by this method, that is prepared by this method, is not pure. It contains about 1% of argon as impurity, because if you look at this setup, you are going to see that there is no chemical that we have used to remove argon from that air and noble gases. So because of that, the nitrogen that you are collecting in the gas jar also contain about 1% of noble gases as impurity. Hence, because of that, this nitrogen that we have collected using the method of air is denser than the one collected from nitrogen containing compound. So take note of that. It is denser than a pure nitrogen. Alright, you can also produce nitrogen from nitrogen containing compound. Example is from ammonium dioxonitrate 3, NH4NO2. So how do you do that? They want to decompose NH4NO2 using heat. However, this kind of reaction is highly exothermic and explosive, and because of that, we cannot heat NH4NO2 directly because of the explosive and the exothermic nature of the reaction. So how do we now do it? Instead, we are going to mix two compounds that can produce NH4NO2. So those two compounds, we are going to mix them together and heat them. So it will give us the NH4NO2 that we desire and help us to decompose it and produce nitrogen from that mixture. So what we use majorly is a mixture of NaNO2, that one will supply the NO2 part, and NH4Cl, that one will give us the NH4 part to give us NH4NO2 and NaCl. So the heat will now decompose the NH4NO2, that's the ammonium diisonitrate 3 that we need, so that we needed to produce nitrogen. So once it is heated, we are going to get our nitrogen, as you can see the diagram from the screen. Another way of producing nitrogen gas is by reduction of nitrogen 1 oxide using copper. So when you pass nitrogen 1 oxide gas into copper turning in a combustion tube, the compound will be reduced into ordinary nitrogen, which you can collect in the gas jar. You can also produce nitrogen by the oxidation of ammonia. Ammonia, if you pass it through heated copper 2 oxide, ammonia will reduce the copper 2 oxide into ordinary copper, which is brown in color, and then that ammonia itself will be oxidized to nitrogen. So you can see in the diagram here, in the structure here, once you have formed the nitrogen alongside water, so the U tube will help to cool down the steam, while nitrogen will go ahead into the water trough and be collected over water. And do not forget that you cannot collect nitrogen by air displacement, because the density of nitrogen is approximately that of air. So we are left with collecting nitrogen over water. They can also produce nitrogen from the thermal decomposition of ammonium heptazodichromate 6. When you heat this compound, ammonium heptazodichromate 6, it gives us nitrogen plus chromium 3 oxide and plus water. So that's how you form nitrogen in the laboratory. How do you prepare nitrogen industrially? You produce nitrogen industrially by fractional distillation of liquefied air. The same way we produce oxygen, that same method also produce nitrogen. How do? You remove CO2 and water from air. Remove CO2 by passing the air through caustic alkali, sodium hydroxide or potassium hydroxide in each case. Next, you remove H2O using dry agent. Concrete sulfur can do that job, or anhydrous calcium chloride. You pass the air into that drying agent, so you have removed CO2 and water, remove dust particle. So next, you are left with only nitrogen and oxygen and noble gases inside that mixture. So what you do next is to liquefy the mixture by subjecting the purified air to successive compression and expansion, heating and cooling process. Then at minus 200 degrees Celsius, the air will become liquefied. So once that air becomes liquefied, you can now begin the process of fractional distillation by boiling. So once you do that, nitrogen, which is more volatile, will boil out first at negative 196 degrees Celsius, leaving behind oxygen, which is boiling point of minus 183 degrees Celsius. So this is how you separate nitrogen and oxygen from air. and this is an industrial method for producing nitrogen. In the next video, we are going to look at the properties of nitrogen, both physical and chemical. God bless you. Amen.